Welcome to this video on technical debt. Technical debt is a concept that explains the future cost of quick solutions in software development. It's called debt because, just like borrowing money, when you take shortcuts now, you have to pay back with interest later. Think of it like taking out a loan to buy something today instead of saving up. You get what you need now, but you'll pay more for it in the future. In software, this means choosing fast but suboptimal solutions over well-designed ones, which creates costs that must be addressed eventually. Technical debt is created by several common situations in software development. Time pressure is a major cause, where developers rush to meet deadlines and resort to shortcuts. Skip testing means code is released without proper verification, leaving bugs unfixed. Poor documentation makes code harder to understand and maintain later. And bad architecture creates weak foundations that make future changes costly and risky. Each of these factors contributes to technical debt, but the common thread is prioritizing speed over quality. Technical debt follows a predictable pattern of evolution. First comes creation, where a quick fix is chosen for speed. Then accumulation happens as more shortcuts are added over time. Next, interest accrues, meaning development velocity slows down as developers spend more time working around problems. Finally, crisis strikes when the system becomes so hard to work with that changes become extremely difficult and expensive. This progression shows why addressing debt early is much easier than ignoring it. There are four main strategies for managing technical debt. Prevention first means writing automated tests, documenting code properly, reviewing code quality, and planning architecture upfront. Active management involves allocating 20 to 30% of development time to refactoring, using static analysis tools, scheduling regular code reviews, and prioritizing the highest impact fixes. Measurement requires tracking code metrics, monitoring velocity changes, measuring test coverage, and assessing complexity levels. Finally, team practices include pair programming sessions, team awareness training, collaborative architecture decisions, and establishing a clear definition of done. Knight Capital is a stark example of technical debt consequences. In 2012, developers recycled old code with minimal documentation and testing due to time pressure. Before the buggy system could be stopped, it purchased $7 billion in unauthorized stock. The company lost $440 million and was forced to be acquired by a competitor. One unchecked shortcut destroyed an 18-year-old company. This demonstrates how the cost of not managing technical debt can be catastrophic. The year 2000 problem, or Y2K, is perhaps the most famous case of technical debt. In the 1960s and 70s, developers saved precious memory by storing dates as 2 digits, like 63 instead of 1963. This shortcut continued for decades as code stayed in use far longer than expected. As the year 2000 approached, thousands of businesses and governments realized date calculations would fail at massive scale. The cleanup effort cost an estimated $100 billion. One choice made in 1970 cost billions 30 years later. The impact of technical debt can be measured in concrete numbers. Developers spend approximately 50% of their time on technical debt instead of new features. Productivity is 2 to 3 times slower in systems with high technical debt. Bug rates are 5 to 10 times higher in code bases with significant debt. Changes cost 4 times more or more to implement. 62% of developers cite technical debt as their top frustration at work. Most importantly, the effect is exponential, accelerating over time without active intervention. To pay down technical debt, you need 4 key strategies. Detection involves code reviews, static analysis tools, measuring test coverage, and listening to team feedback. Prioritization means assessing impact on velocity, evaluating risk, understanding business impact, and calculating return on investment. Allocation requires budgeting 20 to 30% of each sprint, creating dedicated refactor tasks, doing pair programming sessions, and scheduling modernization sprints. Finally, measurement tracks metrics over time, monitors code health, measures velocity gains, and tracks bug reduction. Here are the most important points to remember. Technical debt is not just a code problem, it's a business problem. Small shortcuts compound into exponential costs over time. Prevention is always cheaper than cleanup. Some technical debt is acceptable if it's intentional, but unintentional debt is bankruptcy. Allocate 20 to 30% of development time to managing technical debt. The cost of ignoring debt always exceeds the cost of addressing it. Remember, the best time to address technical debt was yesterday. The second best time is today.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.